So we've talked about how to build a stack, we've tested it. So what can we use it for? Because it seems pretty simple since it's limited. It's essentially a linked list that the only thing you can do with it is add to the head and remove the head. That's all you can do with it, right? That seems to be the only thing. Or tail from your perspective, but honestly, that's all we can do with it. We can just add and remove to one area. And surprisingly, you can do a lot with that. Okay. Stacks are extremely powerful. So one of the problems that we can use stacks for is for finding palindromes. So a palindrome, if you have not heard the term before, you've probably seen them before, are words like kayak or radar, which are spelled forward and backwards, but we can extend it out to entire phrases. I saw I was I. Abel was I ere I saw Elba. Level, Madame, level. We typically ignore the case, we ignore punctuation. My personal favorite is a man, a plan, a canal, Panama, which is pretty long. So we want to write a program that reads in a string and determines whether or not it's a palindrome. So the way it would kind of work is like this. So let's go into a text editor. So say we've got the word taco, and we want to check if taco is a palindrome, and then we'll check it against another word, or check if another word's a palindrome. So what we would do is that we'd go and iterate through all the letters in taco. Imagine that line 5 is at the top of the stack. So we'd push in T, then we'd push in A, then we'd push in C, then we'd push in O. We'd push in, basically, we'd go through each letter and push it onto the top of the stack. And what you'll notice is that we've put taco in the stack, and as a result, it's been entered in reverse. So you've got OCAT, right? If we pop it out one letter at a time, we'll get O-C-A-T, which obviously doesn't match, right? If we pop out everything, we'd get OCAT. So we can just simply check those two against each other. But we can also just short circuit this process, and we can just simply do character by character and say, oh, T versus O, they don't match, so the entire thing doesn't match. So that's what we're going to build, right? So I'm going to use the stack that we used, right? Stack from stacking queue. Stack of character is equal to stack is. Let's go ahead and actually just make it a function. Public static void boolean is palindrome. And I used to give this as a homework during the exam week, but it's pretty straightforward. String word, and we're going to check if that's a palindrome. Okay, or is it, wait, did I spell it right? Palindrome. Yep, so I did. Okay, so first thing we're going to do is create that stack of characters that I was talking about. Stack is equal to new stack. All right, now what is the next step? Well, we're going to take each letter from the word and push it into the stack. So and I'm actually going to do for each character. For each character C in, well, this doesn't work, right? Because that's not how that works. But actually, I can do a two char array, and it will turn the string into an array of characters, and I can iterate through that. So stack dot push C. All right, now for int I is equal to 0, I is less than, so we're going to iterate now through each character. Right, and I could have done this for the above loop, but I wanted to show what two character hat was. So yeah, you can turn the lights on. 2.length. Char C is equal to stack.pop. So we're going to pop off the top of the stack, and if C, and we can use double equals here. C is equal to word.char at. We can use double equals because we're comparing primitives is equal to I, then we don't do anything. It's if they're not equal, what we'll do is return false. Let's return true, right? Return true over there. And let's just run through that, how it would work on a palindrome. Taco cat, right? So here I would push in the T, push in the A, the C, the O, but then the C, then the A, then the T, taco cat. So then we'd pop out T, A, C, O, C, A, T. Each of those would match. You'd get through the entire thing, so it's a palindrome, right? So let's go ahead and say Sout is palindrome, right? Is palindrome kayak. And run this. True. Okay, and what about kayak? False. Okay, so now what about basically for characters that are, what if we only want to care about letters? Well, what about C dot, one thing we can do is do C dot, so if C character dot, let's see, is alphabetic. If character is alphabetic, push it onto the stack, and then we'll do the same thing here. Let's see. If C character dot is alphabetic, C, so check them, otherwise space, we just skip it. Oh, actually this wouldn't work. We'd be working off this thing we popped off of, and we only want to pop off if we're actually got something there. So word.character at I. Boom. So now it should still work with what we have. Shouldn't get any blowing up errors. False kayak. True. But now I'm hoping that if we do this, and then if we do this, so now I can type in all lowercase, a man, a plan, a canal, Panama, true, add in the S, false, add in a F over here, false. So this works. So this is just simply using a very simple data structure, the stack, as a way to reverse the string very easily and just go through things. So that's amazing what we can do with just such a simple data structure.